Okay, cathode ray oscilloscope. Okay, this topic, electronic, have 4 subtopics. Okay, 4 subtopics. The first subtopic is you learn about cathode ray oscilloscope, CRO. Or in Malay, they tulis oscilloscope sinar kathod. Okay. So, the next one is you need to understand semiconductor. Okay, 2 type of semiconductor being doped, P-type and N-type. Because using these 2 type of semiconductor, they produce 2 electronic devices. First, diode, and the second one is transistor. So to understand diode, to understand transistor, you need to understand semiconductor first. Okay. After that, the last topic is logic gate. Okay, gate logic. So gate logic, for me, I think is simple. It's easy for you to understand because, but you need to do more exercise on it. Right? Welcome. Who's just coming in? I'm not sure who's coming in. So welcome to all of you. Okay, we're going to start with the first subtopic, which is cathode ray oscilloscope. Okay, so basically cathode ray oscilloscope, let me show you the other notes first. Okay, so cathode ray is okay. So I share this one first. Okay, basically same note. Okay, this is cathode ray oscilloscope. Okay, so to understand cathode ray oscilloscope, this is the device. Okay, this is the device. You have this in your lab. Maybe similar, maybe not similar to this, but it have the same function. Okay, so this is the screen. Okay, this is the screen. So in CRO, what you learn is, this is the screen. So basically, this is the screen. So it's like you're watching these devices from the side. So what is the component in the CRO? Okay, you learn what is the component in the CRO. Okay, so to understand how CRO works, okay, CRO works based on the concept of thermionic emission. Okay, so here you say the thermionic emission is a process of escape of electron from a surface of heated metal. So metal is here at the back. Okay, we call it a cathode. Okay, it's a metal actually. When you switch it on, there will be a current. So when the current flow, the cathode will be heated. So when the cathode be heated, okay, electron will going up, which is electron will escape from that heated metal. The process name is thermionic emission. So cathode or electron is negatively charged. Negative charge attracted to positive. So we have 3 positive plate. First is grid. After grid is focusing anode and accelerating anode. Okay, so these 3 parts, we call it as electron gun because it produce an electron, okay, that move. So that electron, we call it as When you have many electron, we call it electron beam. Okay, this electron beam also known as cathode ray. Okay, this electron beam also known as a cathode ray. So what is the function of grid, focusing, and accelerating? Okay. So focusing anode is simple, to focus the electron beam. Accelerating anode to accelerate the electron beam. So for focusing and accelerating, a function is really clear because the function is named after the part, which is a focusing anode to focus the electron beam, accelerating anode to accelerate the electron beam. Okay, what is function of grid? Grid is to control, okay, the function of grid is to control the amount of electron. Control the amount of electron. Okay, control the amount of electron. So basically, grid for control the brightness. All right. So electron will move, electron going out. So grid is like a custom, macam orang custom. So orang nak keluar, dia control berapa orang boleh keluar. So itu function grid. That's a function for grid. Okay, we control the amount of electron. So how many electron can pass through? That's a function of grid. So after controlling the amount of electron, focusing will focus the electron, and accelerate will accelerate the electron straight to the screen. Okay, so straight to the screen. We have a pentafloor screen. When they hit, it'll produce like this, a dot. Okay, if you just switch it on, the dot will be on the center. Okay, you switch it on, the dot will be on the center. Right. So there's two main button at the bottom. Y gain, which is this one is Y axis. So Y axis will tell you about the volt. Y axis will tell you volt. So Y axis is volt. And time variable is in X axis. So X axis will give you time or period. Okay, time or period. But in X axis, you can switch it on or switch it off. Right. So the CRO basically you learn is when you connecting a battery or when you connecting alternating current, what will be the output of the CRO? Okay, so the output of the CRO is the one that I give you in the notes, which is, where is it? Okay, which is this one. Okay, so here you can see that we have a DC output, DC, and alternating current. So DC basically from the battery, AC is from a power supply. Okay, so if you just on, it will be here. But when you connecting to a battery, for this one example, the dot move up. Okay, so you see these two, there's no change in X. For this one, it's only in Y. This one also in Y. there's no output on x-axis because the base, the time is off. The time is off. If you push the on button for the time base, you on the button, so it will be, the output will be like this. Okay, it show you the variation of the volt with time. Okay, then this one, a sinusoidal is like a wave. You learn a wave, chapter 1.5. Okay, the sinusoidal show you that this is an alternating current and the time base is on. Okay, so focusing on that, most of the time, equation will focusing on this one. Most of the time, focusing on alternating current and the time base is on, because you need to go back to your fundamental understanding about wave. Okay, so that's all that you need to understand for CRO. So first thing, how CRO works. First, CRO works based on a concept of thermionic emission, which is escape of electron from surface of heated metal. And then you need to remember the component of CRO inside the CRO, from a cathode, grid, focusing anode, accelerating anode, Y plate, and also X plate and screen. Okay. Then you need to know what is the output. What is the output if you connecting to a battery? Okay, when the time base is on or off, and when you connecting to alternating current, when the time base is on and off. This is one of important subtopic in this topic. Okay, so we go back to the note I share you. Go back to the note that we have shared earlier. This is one. Okay, so this one. Okay, we start with this question. Diagram show a display of cathode ray oscilloscope. Which statement is true about the type of current and the time base of the display? So, like yesterday, we can, if you have anything, you can type on the chat. Okay. So, Aina answered C. Okay, good. Because this one, you see there's no change in X direction, meaning in X direction, the time is off. And you see in one line, this is alternating current. So the answer is C. Thank you, Aina. Good try. Excellent. All right. Okay, another one is this one. This is another important thing. Never been questioned in SPM, but this question popular in trial examination. Right. So if you see here, it show you a trace of signal display on the screen of cathode ray oscilloscope. The control knob for the time base is 2 millisecond per division, and the Y gain is set 0.5 volt per division. So what is the frequency and the peak of the wave form? So before we answer the question, I want to ask you, either this is an alternating current or direct current. Okay, alternating current or direct current, and the time base, is it on or is it off for this output? Okay, it's alternating current and on. Okay, nice, good. What is the frequency and the peak voltage? Okay, to answer this, when state here that when the question state 2 millisecond per division, it means 2 millisecond per box. Okay, 2 millisecond per box. And Y gain, when they said 0.5 volt per division, meaning 0.5 volt per box, but in the upward direction. Okay, so we starting by finding the volt. Okay, so wave, you learn how to find the amplitude. This is the amplitude you learn in wave. Okay, so in amplitude, so to get the amplitude, there's two box or two division. And then, given that each box is 0.5 per division. So 2 times 0.5, you get 1 volt. So that is the peak voltage. Okay, 1 volt. And then frequency. Okay, how to find frequency? So to find a frequency, you need to know the period. Because to find the frequency, the formula will be F equals to 1 over period. So what is period? What is period? Period is, okay, period is time for one complete oscillation. Okay. So one complete oscillation is here. Then, so this is a complete oscillation. So for complete oscillation, it takes 1, 2, 3, 4, and 5. 5 boxes. So frequency is 1 over 2 milli, okay, milli, time with 5 boxes. So frequency is 1 divided by 10 milli. What will be the answer? So 1 divided by 10, you get 100. Because milli, right? 10 milli. So the answer is, for this question, the answer is B. Okay, so to measure a volt, what you need to do is first calculate the number of box in y-axis, then time it with the y gain or the volt. Okay, and to find period, calculate the number of box in y-axis for one complete oscillation. Okay, then time it with the time base given. Okay, any question or any problems? Can you understand this part? Okay. Anyone have a problem? before I continue with the next question. Okay, so next question is this. Which particle is a cathode ray? Okay, what is your answer? Which particle is a cathode ray? Oops. I've told you earlier that cathode is electron. So cathode ray is electron beam. Okay, cathode ray is electron beam. So we go back here. So this red dot is electron beam. Okay, nice try Akasha, thank you. Okay, so go to another share screen. Okay. Okay. All right. So look at the picture. So based on the picture, what is the output that the CRO shows? Okay. What is the output that CRO shows? Is it alternating current or direct current? So is it, okay, Aina answered is AC, alternating current, and the time base is on, right? So the question for this is, which trace is formed on CRO if the time base is off? Okay, which trace is formed on the CRO if the time base is off? Okay, so Aina answered on the chat D. Okay, any other answer? Any other answer than D? Okay, everyone agreed D. Christina said it's C. Okay, so looking back at the question, you have this output, you have this output. So this output is for an alternating current because it's sinusoidal and the time is on. The question asks, which trace is formed if the time base is off? So if the time base is off, the answer will be D. Okay, so for C is a direct current and time off. For B is also a DC but the time is on. A is what we have learned yesterday. This is a DC generator. This is what we have learned yesterday, the output for direct current generator. So to show the output, we connecting the generator to the CRO, okay, to the cathode ray oscilloscope. All right. So I hope you understand the very fundamental of cathode ray. So we move to the second subtopic, which is the semiconductor. Okay, semiconductor. So semiconductor, basically, this material, if you have a periodic table, semiconductor lie on group 14. Okay, semiconductor lie on group 14. Group 14, example of semiconductor is silicon and also germanium. So both element is in, okay, both element is in group 14 of periodic table. Okay, germanium. So both in group 14. So when we talk about group 14, my question to you, how many electron valent? Okay. How many electron valent in group 14? You learn in chemistry group 17, group 18, group 1, group 2, and period 3. That's what you learn in chemistry. But if you have group 14, how many electron valent are there in group 14? Najwa said 4. Okay, good, excellent. 4 electron valent. In group 14, there's 4 electron valent. So how many electrons they need to make it stable, which is to reach an octet arrangement. Okay, so because they have 4 electron valent, so they need another 4. So 4 electron valent, they need another 4, then they reach an octet, which is 8. That's basic of chemistry that you learn in Form 4. Okay, so because there's 4 electron valent, so what semiconductor do? They share their electron with each other. Okay, they share their electron with each other, which is when sharing, you know, there's a covalent bonding, the chemistry. Okay, so because of that, one of their property is they can conduct electric, okay, semiconductor, which is it can conduct half, partially conduct electric, partially insulate electric. So it's like half, partially. Okay, but the best property of semiconductor is when the resistance is high, when the temperature is high, resistance become low. So that's the best property of semiconductor. Therefore, because of that property, scientists try to find how to increase its conductivity, meaning to increase ability to conduct electric. So to increase the ability, they found a process named doping. Okay, they found a process named doping. So doping is the process to increase conductivity by adding a specific impurities to increase conductivity. Okay. So what is the impurities? Okay, there's 2 impurities being added. First from group 13, the second one from group 15. Okay, group 13 have 3 electron valent. So 3 electron valent plus with 4 electron of semiconductor, you only get 7. So they need another 1 electron. Because they need another 1 electron, there's a hole for another electron to move in. Okay, so this semiconductor now, okay, when silicon being added with group 13, it's not become silicon anymore, it become a p-type semiconductor. Okay. Then if you dock with group 15, you have 5 electron valent. You dock with semiconductor 4 electron valent, you got 9 electron, which is you have an excess electron because the octet is 8. So now this semiconductor is not called silicon or germanium anymore, it being called N-type semiconductor. Okay, both conductor p-type and n-type is a better conductor compared to silicon alone, compared to germanium alone. Okay, this p-type semiconductor and n-type semiconductor is a better conductor. Okay, basic of this, okay, a trivalent example of trivalent is boron. Example for group 15 atom is phosphorus. That is the atom that you need to remember. Phosphorus and also boron. Phosphorus is group 15, boron in group 13. Okay. So if you have a question like this, doping is a process of adding certain amount of specific impurities to semiconductor. What is the purpose of doping? Okay, what is the purpose of doping? Okay, the purpose of doping, good Akasha, is to increase conductivity of semiconductor. So this is important because after this, we have around 1 minute. So after this, we go to these two components. Okay. When you have a p-type, which is, remember back that p-type have a hole and n-type have an excess electron. Okay, when you put the p-type and n-type together, you get this component named diode. We learn diode after this. Okay, diode. Okay. Then, if you have a p-type, which is have a hole, n-type have electron, and you put another p-type, you got this one, PNP transistor. Okay, and last one, when you have NPN, this is as electron, hole and electron, you get another NPN transistor. Okay, so that's a very fundamental. We'll be resting for 5 minutes after this. Then I give you the new ID and try to go through back the notes about the semiconductor. And after this, we continue with a diode and transistor. Okay, so hopefully you understand until now. Okay, try to digest all the notes before we go to